is Malika and I will be demonstrating these experiments in the following video. For this experiment, we will require a glass, a piece of paper, a pencil in order to roll the paper, as well as some matchsticks. We will also require a clip to support the paper roll. Ever seen smoke flowing like water? So let's begin. Take a piece of paper. Now using the pencil, roll the paper. Roll in such a manner that it has a longer length. Tightly roll and wrap the paper so that it is stiff and the air does not leak from the middle of the roll. Now seal this tube with the help of a tape. Take a glass and with the help of a clip, place the roll in such a manner so that it stands vertically and parallel with the glass. With the help of a matchstick, light up the top of the tube. What will you observe? You will observe the smoke to fall down from the tube like a waterfall rather than flowing into the air. Now, you may ask why. It is because when the paper burns, it breaks down millions of gases and water vapors. Normally, these molecules are heavier than the air, and the flame excites these molecules and makes them lighter than the air. This makes the smoke rise when there is a normal fire. In this experiment, all the hot smoke molecules are trapped inside the paper tube, which prevents them from rising. And these trapped molecules are given time to cool off, which releases the energy and allows them to be lighter than the air. The cool smoke molecules fall instead of rising and escape out from the other side of the paper tube. Let's take another example towards the flow of smoke. You will require a foil paper. Tear the foil paper into a piece so that we can make a tube out of it. We will now take a paper tube and place some matchsticks over the foil and at a position above the tube and roll it along with the foil to finally make up an entire tube. We will seal the foil on the top so that the smoke does not escape from the top of the tube. Again, using a clip, we will support our tube. We require a chilled glass, a tube, and a matchstick. Now place the tube inside the glass and light up using a matchstick which is inside the foil. Kids, while trying the experiment, should seek their parents' help. We see gas rushing through the tube and setting inside the glass. So are you ready for the show? Let's see how the smoke flows. I have also performed the same experiment without using a chilled glass. So when the density of a molecule is less than its surroundings, it will rise. Thinking of a hot air balloon, when we heat the air inside, the air rises up because the heat causes the molecules to expand and become less dense. As we are cooling the molecules as soon as it is coming out, we are actually able to make it dense and heavier than usual. This is why it pours so easily. It is daily used in backflow incense cone burners as a gift that helps to clean your space and eliminate both the undesirable odors and negative energy. Another application is it is used to trap the chemicals inside large containers in industries. For this experiment, we will require salt, a glass, some ice cubes, chilled water, and thread. Now take a glass and pour some chilled water in the glass. Drop in some ice cubes and then place the thread over the ice cubes that are floating on the water. Take some salt and drop it over the ice cubes. After adding the salt, wait for around 2 to 3 minutes. And now you can lift up the ice cube using a thread. You probably might be wondering why it happens only when you sprinkle salt over the ice cubes. When you sprinkle the salt over the ice, it dissolves in a thin layer of water above the ice. Because the salt water freezes at a lower temperature than the pure water, adding the salt makes the ice melt and absorb heat in the process. The area just around it thereby cools and freezes the water molecules to the ice cubes, also freezing the string on it. One of the most common ways to de-ice outdoor surfaces or road is to sprinkle rock salt over them. Also, ice, water and salt is used as a clever science hack to chill the drinks in less than 5 minutes. For this experiment, we will require a pen refill, some Fevikwik or glue, a stick, and around 15 to 20 glass marbles. Now, cut the refills into short pieces. Take a yarn of wool or some thread. Stick the short cut refills onto the marble using our glue. What do you think is a pendulum wave? It is a physical effect based on the series of independent pendulum that are finely tuned relative to their oscillation periods or the frequency. The oscillation period of a simple pendulum depends not on its mass but rather on its suspension length. Using a measure tape, we will secure 15 independently swinging pendulum to a stable frame. These are some measurements which are often used while making a big pendulum wave. We will be modifying these measurements into centimeters to tie the thread with the marble. Now tie each of the marble, making them a pendulum to the given stick. When we will now tilt the pendulum out of its position of equilibrium, it will acquire potential energy. When this is released, it begins to move according to the gravitational force that acts on it, completing an arc directly proportional to the length of its suspension length. Each pendulum now has a different suspension length and thus have different oscillation frequency. If the longest pendulum makes around 51 oscillations per minute, each following shorter pendulum will complete one more oscillation per minute than the previous one. This causes the pendulum to dance in waves. It is used in pendulum clocks, which increases the timekeeping accuracy from 15 minutes to 15 seconds per day. Pendulum rides are also a best example when speaking of pendulum wave. It is also used in seismometers as it sways to activate a lever after earthquake tremors.